Hi guys, let's continue building our app to compute the geometric series. Let's check what we did last time. We created this panel here where we can control for the coefficient A, for the common ratio R, for the number of terms. Then we can choose if we want the n term or the sum of the n terms. And this is what we did last time. We push compute, and we have here the n term for this geometric series. We can change here, and this is the sum, this is the converging value. Now, what we can do? We can add this input here, where we can plot the solution. So now, if I go here, compute, and as you can see here, we can see that this geometric series is converging to this value, 7.1428, and so on. We can check the n term, and naturally, the n term is getting smaller and smaller, converging to 0. So this is what we are going to do. So let me show here. This is our app, and this is the user interface. What we have to add with respect to the previous script is this select input. Select input plot is the ID. Do you want a plot of the solution, the label, and the choices no and yes. Additionally, I changed the ID of the action button, so now it's button. Then we add plot output gs underscore plot. Okay, so now let's go into the server. So okay, now out, we have to write a little bit more. So event reactive, this is the same as last time, input button. So we wait that the user push the button to proceed with the application. And we require these inputs, A, R, N, and plot. So if input plot equal no, this is the same code as last time. So absolute value of R is different from 1 and input select is the n term. This is the formula that we are going to code here. So input A times input R to the power of n minus 1. And we nest this in format function and set the scientific equal false because we don't want the scientific notation. Else, if the absolute value of R is different from 1 and input select here equal the sum of the n terms, we implement this formula here. So A times 1 minus R to the power of n plus 1 over 1 minus R. Then we have to consider if R is equal to 1 and R equal minus 1. In the first case, we repeat the input A, the coefficient A, n times. In the second case, we replicate the coefficient A and minus A n times. And this is what we have done last time. Now, else, if input plot equal yes, so we want a plot of the solution. So now what we are going to do, implement a for loop. So if the absolute value of R is different from 1 and input select is equal to the n term, we implemented this formula. So we initialize an object that will store the result of the loop. So for I in this sequence, we are implementing this formula. So input A times input R to the power of I minus 1, where I is given by the numbers in the loop, and they're stored in the res object. And then we return the res object. Else, if the absolute value of R is different from 1 and input select is equal to the sum of the n terms, we implement this formula. So again, we initialize the object, we use the loop, and here, this is basically this formula here. So A times 1 minus R to the power of I plus 1 over 1 minus R. And we return the object. The case here, R equal 1, R equal minus 1 are the same as before. Just remove the print message. Now that we generated the data, we want to plot them. So we make a linear plot. Again, we wait for the user that push the button, and we require again this input. So if input plot equal yes, we make this plot here. So for okay, we generate here the data for the x-axis, out here the geometric series, type equal L because we want a linear plot, we set the X label and the Y label equal to input select. Then here we render the plot, naturally if we have a plot to render, and we enter the code out is the result of the geometric series. And that's it. This is how that app works. So let's run now together. Let's play a bit. So let's set here. And as you can see here, the n term is getting larger and larger, meaning that if we check the sum, this value is not converging. As you can see, it's getting larger and larger. And naturally, this is due to the fact that r, the absolute value of r, is greater than 1. If we go here, 0.7, so we have absolute value of r less than 1. We do like this. Now we see that the value is starting to converge. Let's increase here. And as you can see, it's converging to this value, 16.66667. And naturally, if we check the n term, it's getting smaller and smaller, converging to 0. Now, let's put here a minus. What happens is that it's oscillating, but as you can see, it's converging. This is the n term. Let's check the sum. And again, oscillating and converging to this value, 2.94 and so on. What about if we have a negative value like this? And as you can see now, it's oscillating but diverging. What about if we have -1? And here we're just alternating the value of the coefficient a and minus a. If it's just 1, we have a straight line. So that's it for this video. And I hope the video is interesting, and if you enjoyed this video, see you in the next one.